Hi, IEEE members. Let me introduce the submitted paper, IEEE Access 2020-19316. The title is Detection of Spliced Image Forensics Using Texture Analysis of Median Filter Residual. The presenter name is Kong Hyeon Ri, at Chosun University in Korea. The main words of image forensic detection from the state-of-the-art are shown in the word cloud in this figure. To summarize with the words, the median filtering is a lot of manipulation in image forensics, and feature definitions are needed to detect a spliced region. In this figure, a forger selects the region to be unaltered C, and the region to be transformed D in the original image A. On the left side of D. The modulation methods of the paste region include nonlinear median filtering, linear average filtering, and compression JPEG, etc. The region C and D spliced with each other E. Like visually the original image A. The forger tries to avoid the copyright problem with the spliced image E, which, if it was not duplicated by posing like the original image A. In the detection of median filtering, the median filter residual (MFR) is most frequently used as a pre-treatment. In this figure, suspicion image YA, its median filtering image Z B, and the difference image D C between Y and Z are depicted. Any part of the image A is manipulated. The MFRD is formulated as the equation. Texture analysis uses statistical measures to classify textures. It can detect the object borders that are presented more by texture than by the luminosity. The entropy filtering operation, which computes the entropy of the neighborhood around the correlated pixel in the grayscale image, and allots that value to the output pixel of regard. Furthermore, the range filtering operation, which detects regions of texture in an image. The pixel of the texture contains the range value, maximum value minus minimum value of the neighborhood around the corresponding pixel in an image. As mentioned above, the operations in a similar way. They define a neighborhood around the pixel of interest. Calculate the statistic for that neighborhood, and use that value as the value of the pixel of interest in the texture image. Entropy is computed based on the below. Where P L is a normalized luminosity histogram put out by obtaining a luminosity histogram H L for the image area whose properties to be measured. If a luminosity value is L equals 0, 1, 2. L-1, followed by dividing the frequency of each luminosity value by the total frequency, a pixel number of the image area, and then normalizing to compose the total pixel number. A transformed image, example, median filtering, average filtering, JPEG compression, etc. is to be smooth, which is little variation in the gray level values compared to an unaltered image. Therefore, an unaltered image exhibits more texture, and pixels have more variability and, thus, higher range values. In this paper, texture analysis would be used because the difference of the entropy can be classified as the cut-paste region in spliced images. Be comprehended. The main contribution of this paper is as follows. For detecting an unknown state of the spliced image, its MFR is decomposed to obtain the local entropy and the local range, and then their texture is analyzed. In the texture analysis, a local entropy generates the GTM ground truth mask using the FGM find gray level regional maxima of closing by image reconstruction, and also the entropy-based edge for the border generated between cut-paste region of a spliced image. A local range generates the GTM using a morphological open erosion for the separation of the cut-paste region in a spliced image. Furthermore, the implemented detector of image forensics does not need a trained classifier, when test a spliced image. When any part of the image itself is manipulated, the part can be classified with the proposed detector. In this paper, for the spliced image forensics, a new image forensic detection scheme is proposed, in which the feature vector extracted from the texture analysis of MFR. Proposed image forensics detection scheme. Step 1. Input a spliced image A, which has cut and paste region both as in the slide number 3, the image E from the spliced image example E. Step 2. B is median filtered from A, and a median filter residual MFR image C is drawn by the difference between A and B by the MFR equation. Step 3. Texture analysis of C is drawing the two images, one is the local entropy LA D, and the other is the local range LR E of the MFR image. LA and LR are formulated as the equation 8 and 9, respectively. Step 4. LE D and LR E images. In this sub-step, there are 5 ground truth masks (GTM), which masks classify the cut-paste region in the spliced image. The GTM feature set extracted repeatedly with a morphological open (MO) and erosion (ME). Number 1. The first feature, FGM, find gray level regional maxima of closing by image reconstruction, is drawn by a black dash line F. Number 2. The second to fifth features, 2 morphological open images (MOI) and 2 morphological erosion images (MEI) are extracted repeatedly with MO and MI. 2. Then the 4 kinds of the morphological based GTM formed H, I, blue dash lines. Step 5. Lastly, the forgery image detection block. Red dash line takes 5 elements A, F, H, and I as input and classifies the cut-paste region J of the spliced image A, respectively. The detection image J includes a cut region blue color, a paste region the gray scale image itself, and a cut-paste border edge thick black line. From now on 3 slides, a spliced image is to be the median filter residual image, then we will show the 8 kinds of images by analyzing the texture of MFR image. The cut-paste classification results of the spliced images are shown in this figure. The first row is the spliced images with a median filtering 3x3, a median filtering 5x5, JPEG compression by a quality factor 90, JPEG compression by a quality factor 70, and an average filtering 3x3, respectively. The second row is the median filter residual images of each for the spliced image. Also the third row is the local entropy images of each for the median filter residual images. In this figure, the first row is the local range images of each for the median filter residual images. The second row is the FGM images of each for the median filter residual images. The third row is the entropy-based edge images of each for the median filter residual images. Also, the fourth row is the MOI4 images of each for the median filter residual images. In this figure, the first row is the MOI5 images of each for the median filter residual images. The second row is the MEI4 images of each for the median filter residual images. Last, the third row is the MEI5 images of each for the median filter residual images. The BOWS2 10,000 images and the UCID 1338 images databases are used in the experiment of the proposed scheme. In the experiments, the image is converted to 8-bit grayscale images by the necessity for use from the image databases. The 5 types of the feature were extracted by the proposed image forensics detection scheme. which implemented in cubic SVM classifier with 5-folder cross-validation. For training the classifier, the prepared p-data spliced image, and n-data, median filtering 3x3, median filtering 5x5, JPEG compression by a quality factor 90, JPEG compression by a quality factor 70, and average filtering 3x3, which are composed like this. In the proposed image forensics detection scheme, the BOWS2 image number 6221 tested by the spliced ways in this figure. The tamper manipulation of this spliced image is detailed in slide number 3. In the left side image, which from before the slide, the spliced image A to be median filtered B, and its MFR image made C. In the right side image, the defined EBE entropy-based edge, which is in the proposed scheme, depicted F, along with the existing edges, and compared to the existing edge A to E. Where the border edge is classifying the transformed paste, and the unaltered cut region is clear. Also, the transformed region is almost pure, while the unaltered region is represented by its texture. The cut-paste classification results of the spliced images are shown in this figure, according to the 5 features FGM, MOI4, MOI5, MEI4, and MEI5 by an unaltered versus a median filtering 3x3, a median filtering 5x5, JPEG compression by a quality factor 90. JPEG compression by a quality factor 70, and an average filtering 3x3, respectively. On each spliced way, the classification results of excellent and good are shown by which feature selected. Also here the detection ratio of the cut and paste region, those average are computed too. The detection ratio of the JPEG compression by a quality factor 90, JPEG compression by a quality factor 70 transforms slightly lower than a median filtering 3x3, a median filtering 5x5, and an average filtering 3x3 among the 5 features. And the linear average filtering 3x3 and nonlinear a median filtering 3x3, a median filtering 5x5 transform spatial domain of the splicing detection are higher than the compression transform spectral domain. For cut-paste classification of the forgery image, the unaltered image versus the transformed images a median filtering 3x3, a median filtering 5x5, JPEG compression by a quality factor 90, JPEG compression by a quality factor 70, and an average filtering 3x3 were executed on the trained cubic SVM of the proposed image forensics detection scheme. The classified results are shown in the confusion matrix in this slide. The experimental results of the proposed image forensics detection scheme are presented with the 4 test items. Classification accuracy, area under the ROC curve AUC. Probability true positive at probability false positive equals 0.01, and a minimum average decision error PE. This figure shows the ROC curves and AUC, cut versus paste, a median filtering 3x3, a median filtering 5x5, JPEG compression by a quality factor 90, JPEG compression by a quality factor 70, and an average filtering 3x3. Figure A is the proposed image forensic detection scheme. B is the AR10 dimensionality, and C is the 2D AR27 dimensionality, respectively. In Figure A, according to the high probability true positive at probability false positive equals 0.01 of the proposed scheme, the ROC curves A is rapidly increased compared to B and C, reaching 1 on the y-axis true positive rate. Therefore, the proposed feature set has a higher classification performance than the AR and 2D AR. In this slide, about the unaltered image versus a median filtering 3x3, a median filtering 5x5, JPEG compression by a quality factor 90, JPEG compression by a quality factor 70, and an average filtering 3x3, the 4 test item results are shown. The experimental results are compared to those of the AR and 2D AR to verify the performance, where PTP true positive rate, sensitivity, PFP false positive rate, 1 - specificity, PFN false negative rate. The higher value of PTP at PFP equals 0.01, which has the better of the detection ability between the cut-paste classification, and a minimum average decision error PE, which has lower, the reliability of the image forensic detection is higher. Also, this means an equal probability of the positive and negative data, i.e., the positive, cut region and the negative, paste region. In the left side figure, the unaltered image A is cut, and the C image is media filtered, which is pasted in the cut part of the B. The proposed image forensics detection scheme, the AR, and the 2D AR methods applied to the left side figure B. And the classification result of the cut-paste region is presented in the right side figure. The proposed scheme A, D compared with the AR B, E and the 2D AR C, F, respectively. In this figure, the proposed scheme A and D shows the analyzed texture, local entropy and range of the spliced images, and the extracted feature set becomes directly GTM for cut-paste classification. But the AR and 2D AR methods should process the block by block B and C, in here 32 by 32 pixels in spliced image. Besides, these methods require the learned SVM classifier, and the score value for each block are calculated, and cut-paste classification is determined E and F with the score patterns B and C, brightness levels of blocks, which formed by the threshold of the score value. Also, Figure A shows the GTM of the proposed image forensics detection scheme, which generated from texture based on the forgery image, thus has the unit value about the predict region of cut blue color or paste white color, one of the two. Also, Figure B and C show the score patterns, which have the grading rules for each block to examine. In the proposed scheme the GTM, which gives good enough to submit as digital evidence without ambiguity in the image forensics detection. However, the proposed 5-dimensionality feature vector has improved compared with that of the 10-dimensionality AR, 27-dimensionality 2D AR. The results in Figure D, E and F confirm that the classification of the proposed image forensics detection scheme is rated as excellent. In this paper, the detection scheme of the median filtering forgery image is proposed. The performance of the improved feature vector from the proposed image forensic detection scheme has an excellent detection ability to classify the cut-paste region with the specially generated mask pattern ground truth mask and the border edge entropy-based edge. In forensic detection of cut-paste classification, the texture-based processing method of this paper has a higher classification than the conventional block-by-block processing method. This approach will further the research area for a variety of detection of image forensics. Thanks for your attention.